Matt, go for it.
Okay. Thanks, Gregor. Yeah, so Simon has just covered off the various different types of compute that Azure offer, and I will just now go through how they can be used to host a web app, or the various different hosting options. So there are three primary types. So he touched on containers, which can be hosted in AKS or Azure Kubernetes Services. It also can be hosted in ACI and ACA. So ACI is Azure Container Instances, where you have a short-running container that's a single unit that you want to run for a short amount of time, and then it shuts down. Azure Container Apps is a more recent addition to the Kubernetes container infrastructure, which allows for single containers for more kind of long-running jobs. Kubernetes as a whole is quite a complex infrastructure. Microsoft takes some of that complexity away from you by hosting the control plane, so they look after hosting the manager nodes and all the management side of things, but you're still having to create containers and deploy them into Kubernetes or ACI or ACA. The beauty of containers is that it is the same code every single time. You create a container instance with a container which contains all the source code for your own applications alongside any dependencies. So if there's a specific version of Node.js or a specific version of Python that you need to be using, that can be built into the container. So when a developer is developing the application on their local machine, they're developing within a container. That container is exactly the same thing running in Azure. So it follows this workflow where you're building into a container and you get the same code every single time. It falls back to the concepts that Simon was talking around, pets versus cattle. So with containers, you treat them like cattle, and so if there's one that is poorly or ill, you just stop it and bring a new one up, and that is where sort of containers come into their own. Alongside containers, we have virtual machines, where Simon has gone through already. They are the more classic service for hosting websites. They give you the maximum flexibility because you choose the operating system, you choose the web server that you want to host, you choose any dependencies and any applications that you want to be running on that machine alongside your own code. It gives you that kind of precise configuration. It is the very sort of core infrastructure as service unit for Azure. But it does introduce its own overheads and issues, in that you are managing the operating system and the patching and everything that goes alongside it. So it is a very flexible choice, but it's also, there is a maintenance overhead alongside that. The other primary web app or hosting service for web applications are Azure Web Apps, or app service plans. So an app service plan is where it is effectively a virtual machine that is running. So it has a similar kind of compute stock keeping unit, or SKU, as Simon was mentioning. So you pick an amount of CPU power, an amount of memory that you want to be running behind your web apps. This could be used for Azure Web Apps, which are effectively IaaS services running in Azure, but they are also possible to use an app service plan to host Azure functions, like Gregor just talked about. They are a very good platform generally for developers, because it removes the need for any of the hardware management and operating system management. You know, all you need to do is configure the web app itself to host your application. So you're specifying what language you're using, whether you want to use Linux or Windows to host it, and it gives the developer a strong foundation for their application. Microsoft and Azure look after all the patching and all the implementation of any kind of maintenance, so you don't have to worry about that at all. Within the web app service plan and web apps, that there's also options for scaling and high availability. So if you want to make sure that your web app is running all of the time, or at least minimizing any kind of disruption, you can ensure that it's running by having a version running in West Europe, but also a version running in North Europe, just in case something happens to the data center in West Europe where your machine, your web app is running. The app service plans and web apps can host a variety of different types of websites. Just the bog standard website front end. So what you'd see if you go to Microsoft's own websites, or Google, or the BBC. These are all just basic front end websites. They will also, you can also host APIs. So this is where it's more of a developer kind of interface for certain applications, where calls come into the website, but there's no web browser that's sort of driving the interaction with the web app. And then they can also support web jobs, which is more kind of a scheduled maintenance task or kind of upkeep task that you can run in the background. So this could literally be a small script or application that you deploy into your website alongside the other code to ensure the smooth running of your website day to day. So this is the three general options you have. You've got your basic virtual machine, which is your infrastructure as service offering. You've got your web apps and your app service plans, which is more your platform as a service offering. And then you've got the variety of different container offerings, which cross that boundary between infrastructure as service and platform as a service.
Mark, can I ask a question?
Yeah.
Could I host, if I wanted to move my blog off of WordPress, not even just WordPress, could I host my blog on Azure websites, for example?
Yes, yeah, you could host a blog on there quite easily. There's a variety of different ways you can go about hosting that. If the pages aren't dynamically generated or have any kind of complex code running behind it, you could even host it in something like a storage account, but that's kind of going into a little bit more kind of technical detail than is needed for the AZ-900. But yes, you could easily host a blog on an Azure web app, because that's what I'm doing. That's where my blog sits.
Where can we find your blog, Matt?
I'll pop it in the chat afterwards, because I can't quite remember if it's actually running.
Can I ask you one more question?
Mm-hmm.
So at what point would you say, like, let's say we have something running in a virtual machine, and at what point would you say it would be best to actually move that to AKS instead of having that in a virtual machine?
It really depends, I think, is the consultant's answer to that. The base issue would be what operating system they're running on, the complexity of the application. If it's a simple web app or web application, then you could containerize that quite easily. Containers are more of a service that lends themselves to a development framework called microservices, where each sort of little function has its own container in its own little world. So everything is split up. So if you have a gigantic single application that is running on a virtual machine, yes, you could put that into a container and you could run it in Kubernetes, but you would get no real added benefit over running it in a virtual machine, other than that you could scale up multiple versions of it quicker. It's so there's it goes on a case by case basis. I think is the best way to put it. But more modern development methodologies and sort of processes kind of lend themselves more to kind of microservices and Kubernetes. It's sort of over the last 5 or so years, it's been building a momentum as the de facto container hosting platform, but also containers are kind of becoming the de facto way developers create their applications. So it's easier to bring them into services like AKS, or you could host your own Kubernetes services if you so wish. It doesn't have to be a managed offering that Azure provide. There are people out there that will run their own versions. It just means that you're then paying for the virtual machines to run the management side of things as well.
Okay, sounds cool. Thank you.
Okay, perfect. Okay, so moving on to networking. So this is a slightly drier topic. So I've got a small demo, but it's a few more slides than what I've previously done. So networking covers a variety of different things, primarily Azure Virtual Networks, which within them contain subnets and the concept of peering. We'll also briefly talk about Azure DNS, Azure VPNs, and ExpressRoute. So these topics I'll cover in the next few slides. So the base element for all of Azure networking, and pretty much anything that you deploy into Azure that needs some kind of access to the internet, will use a virtual network or a VNET. These are isolated networks within Azure, so anything that gets put into a virtual network can talk to only the other resources within that VNet, potentially talking out to the internet if you so allow. You can put any kind of resource into a VNet, sort of from the web apps that we previously just discussed, to things like Azure SQL or Cosmos DB. So the VNets provide a way of communicating between each other. So this is peering, and it also gives you a way of connecting to Azure. So this is where the VPN Gateway comes in, and we'll talk about that later. Each VNet itself is an isolated network. It has its own address range. So this is the 10./16 address down here. So this is the address space of the whole virtual network. Within a virtual network, you can place your resources into a number of subnets. So a subnet is just a portion of the address space of the virtual network. The subnet itself comes with an additional security features called network security groups. And these are a way of restricting traffic in and out of a subnet. It's a way that you can kind of control what is happening to your resources and which resources can talk to each other. So you have this is the base unit for kind of controlling the communication between the various resources within Azure. So within a VNet, you have I think, did I miss a slide? No. So within a VNet, you can deploy services, and they can have either a public endpoint or a private endpoint. A public endpoint, as the name suggests, it's publicly accessible. So this is a resource that can get out to the internet, but also the internet can get to it. So most web apps or virtual machines that are hosting web services would have a public endpoint. Services more like your databases or Azure Functions potentially could sit behind, but within Azure and not have any public access. So if you're sat on the internet and you're trying to access these resources, you just can't get at them. So the public endpoint is accessible to anybody that has the correct credentials. This could be open to the internet just generally, or with authentication to ensure that only authorized people access those resources. And then the converse of public endpoints are private endpoints. These are endpoints that aren't accessible from the internet. So they might still be able to get out to the internet to download patches, to query things themselves, but they are protected within Azure. So the only way to access them is either through another resource in Azure or through a VPN gateway or similar kind of connectivity. Most of the time, the things that you're protecting this way are like databases and services that hold sensitive information. You know, in the most common kind of setup is that you would have a web front end that is running your code and querying things, but that's not where your data sits. Your data sits in a SQL Server or a Cosmos DB or even a storage account, or just something that removes it from the front edge of your network. So those are the two types of endpoints. You know, kind of you might get asked the odd question on it. It's not a big part of the course, but it's something to be aware of, that there are these different types of endpoints that services can have. Okay, so quickly going over to the Azure portal, if I can get the right thing up. So going back to what Lisa was talking about with resource groups, this is a resource group I deployed earlier. It's called AZ-900 Networking. So this is me grouping logically all the resources for this demonstration. In here, I've got a virtual machine similar to what Simon has deployed already into his subscription. This virtual machine has an IP address and is in a VNet. So because it's a virtual machine, it automatically deploys a VNet alongside the virtual machine. You can choose to put it into a pre-existing VNet if one doesn't exist, but for this demonstration, I just created a new one alongside it. This VNet, so the subnet on this VNet will have a security group alongside it. So in this VNet, you can see here's the address space. So this is the IP range that if you put more resources into this subscription, they would get an IP address within this range. In the subnet, there is just the one subnet because it's a basic VNet, and we have one device connected to this network, which is the network interface card, or NIC, for the VM. So it's a very basic networking kind of idea. The virtual network, within it, you can look at within the virtual machine kind of configuration. You have access to networking configuration. Here, this VM that I've deployed is running IIS, so just a basic web server. But at the moment, if you try and access it, you get a site can't be reached because the network security group associated with this virtual machine is currently not allowing any communication from the internet. So it is currently in it is effectively a private endpoint. You know, that there is no way to get to this virtual machine from the public internet. But if we quickly give it access from anywhere to port 80, so the default HTTP port, this will take 30 seconds, but once that has been applied, we should hopefully then get to see the default page that is deployed when you initially set up IIS. So I'm just going to leave that there to sort of sit and think for a minute, but hopefully it will pop into life shortly. But so this is how you can control communication between subnets within the same VNet, but also between virtual networks. You could have virtual machines in different VNets, and you want to limit the communication between one virtual machine to another. This is a potential way of doing it. There we go. So this is now a public endpoint, because anybody on the internet, if you go to that IP address, you will get the same response. Okay, so that's pretty much it from a demo point of view. So the one thing that was on a slide that has gone missing was the concept of VNet peering. So within a virtual network, it is an isolated region or an isolated address space. So the resources that you deploy into them can communicate with each other, but they can't communicate across different virtual networks unless you do a concept called peering. This is where as long as your address spaces don't clash, you can connect the two address spaces together, and it allows communication from one VNet to another. So sometimes, when Gregor kind of alluded to it with the hub and spoke kind of configuration, it comes from networking, where you have a central virtual network where your VPN gateway would potentially come into, and then you'd have separate VNets for possibly a test environment, a dev environment, a production environment, and you could segregate that traffic away from each other, but the hub VNet can communicate to them all through VNet peering. And it is a way that you can communicate between VNets in a kind of secure way, because it uses Microsoft's backbone network, so it never truly goes back out onto the internet again. So you're going across Microsoft's own network to do that communication. So it's a more secure way of communicating between resources if needed. So moving on to the VPN gateway. So whilst you have all your resources sat in Azure, that's all well and good that they can talk to each other, but how do you talk to those resources if they've got private endpoints and they're not internet facing? This is where a virtual private network, or VPN, comes in, and Azure has a service called Azure VPN Gateway. This is where it allows a connection between two or more trusted networks to communicate. So these trusted networks could be completely different locations, and the only way to communicate with each other is over the internet. So you need to build an encrypted tunnel between these two trusted networks to ensure that any sensitive information doesn't fall into the wrong hands. So this is where the encrypted tunnels come in, and where virtual private networks come from. So it's not a new concept. Virtual private networks or VPNs have existed for many years. It's not a cloud only technology. Many large organizations and corporations would have VPNs from one office to another to ensure various different offices could communicate without that information falling, sort of being exposed to the internet. So the VPN gateway for Azure manages the Azure end of your VPN connection. You need to configure a device at either end to enable the tunnel. So the VPN gateway is the Azure end of that tunnel. It sits in its own dedicated subnet. So you create a new subnet for the VPN gateway. It sits alongside your other resources. Doesn't really affect those resources. It just needs to sit there in a dedicated subnet, so it can run and not be disturbed by other things. There are two primary kind of types of VPN gateway that you can, or sort of VPN configuration that you can use: site to site and point to site. So as the names hopefully suggest, site to site is where you're connecting a site to Azure. So this is where you've got a office building or headquarters or branch office that you want to connect to Azure as a whole. So anybody that is sat within the corporate network of that office can access Azure without having to jump through any more hoops. They can just walk into the office, plug their laptop into the Wi-Fi or on an Ethernet cable, and they have access to the resources they need. It's a good way of securing an office to Azure connection, because you have one VPN appliance or firewall sat within that office doing that work to communicate with Azure to keep that VPN tunnel running. The other option is point to site. This is preferred for if you've got a distributed workforce. So if you don't have an office, or if your user base is spread across the world and they all work from their own homes, then having a site-to-site VPN is not correct for that. A point-to-site VPN allows a specific device to connect to Azure directly. This is because there's a client that sits on the machine that's configured with security certificates that will allow that connection. So you might have to authenticate through Azure Active Directory or put in a username and password as well, but that configuration sits on the machine. It's great for distributed workforces, but there's an additional overhead because each machine, whether it's done manually or through sort of group configuration management, needs to be configured to allow that communication to Azure. So without the VPN gateway running, it would just not allow either of these types of connections. Within one VNet, you can only have one VPN gateway deployed at any one time, but you can deploy multiple locations to connect to that gateway. So it doesn't have to be a 1-to-1 ratio. So you can have one VPN gateway that is running 2 or 3 site-to-site VPNs and point-to-site VPNs at the same time. It's just because of the way the networking works, you can only have one gateway sat in Azure. You can have multiple gateways in different VNets, as long as they're not talking to each other. You're not going to kind of run into too many issues. The VPN gateway itself, that there's 2 configuration options you have. So you have policy-based and route-based configurations. Route-based is the more preferred option because it's more resilient to changes in network configuration, because if your branch office suddenly grows and doubles in size and there's extra networks being brought online at that branch office, the routes are automatically pre-populated back into the VPN, so the VPN carries on working. The slightly older and less used configuration is policy-based, where the gateways have to be sort of reconfigured if there's a network change at either end. So it could be that all your changes are happening in Azure, and so you want to kind of keep keep the configurations fresh, then I would stick with route-based, because that's where the resiliency comes in. So with VPN gateways, because it is a tunnel across the internet, it does become a single point of failure to some degree, because if it goes down, then your branch office or your users can't connect directly to Azure. So there are various different ways to make the VPN kind of highly available, so a bit more resilient to a single outage. By default, a VPN sits in an active standby setup. So this means that if the active connection fails for whatever reason, there is another connection that will pick it up. But there will be a couple of seconds to maybe a minute of downtime whilst that switchover happens. This is the default. So if you deploy a VPN with what looks like a single connection, there is a second set of resources sat there waiting. They're just in standby mode. Then they're not actively doing anything. This is done so if there's a planned maintenance, or if there's an outage within an Azure region, there is something to take over. But regardless of whether it's maintenance or outage, there is that little bit of a drop between one connection and the other connection taking over. So you might find that if your communication requires uptime, you need other options. And this is where active comes in. As the name suggests, both sets of resources are actively managing connections from on-site. You can also have multiple versions of your on-site VPN gateway appliance. So you could end up with effectively 4 tunnels across the internet from 2 devices on site to 2 devices in Azure, which, so if any one device goes offline, you've still got resiliency and redundancy between the connections. Because you have 2 separate active connections, these active connections do have separate IP addresses, so it's a bit more complicated and complex when it comes to configuring and ensuring your network flow is correct. But it's certainly something to consider if the VPN connection is vital to your communication. Something that we'll come on to in a minute is ExpressRoute, which is another type of VPN connection or connection into Azure. It has resiliency built in by design, but it still doesn't 100% guarantee an outage. So you could use something like a VPN gateway as an alternative connection method, just in case the primary circuits within your ExpressRoute fail for whatever reason, and then you have a backup kind of connectivity. As Simon mentioned with availability zones, you can also deploy VPN gateways in a zone redundant configuration. So this means that the different gateways that you're using are in distinct data centers within a region. So if for whatever reason a data center or availability zone gets knocked out, your other VPN gateway is completely unaffected because it's in a different building with different network connections and different power, completely segregated away from that one availability zone. So it's a way of physically and logically segregating the 2 gateways apart from one another. So I briefly mentioned it in the last slide, but ExpressRoutes, it's an alternative way of connecting your on-premises networks to Azure. It does so over a dedicated private connection, but unlike the VPN gateway with a more standard VPN connection, the ExpressRoute doesn't go over the public internet. The connection is at a lower level within the networking stack. So the connection should be more reliable, it should be faster, and it should be secure. The ExpressRoute doesn't have to be just for Azure. You can use it for things like Dynamics or Microsoft 365, and you can also use it to connect different offices. So if you have an office in Europe and an office in Australia, you can have ExpressRoute connections into Azure, but your ExpressRoute connection in Europe is going to West Europe, and your ExpressRoute in Australia is going to Southwest Australia. You're then using Microsoft's backbone network to talk across the world effectively. That's a system called Global Reach, and it's a way of kind of connecting distributed offices to each other without going over the public internet. So it's another the kind of way of increasing security for your on-premises networks by utilizing some of the offerings from Azure. So, like I mentioned on the last slide, ExpressRoutes are built to be highly redundant, and this is because the providers of the ExpressRoutes use their devices in a highly available configuration. So there should be additional protection from loss of communication for anything traversing an ExpressRoute. So in the last few slides, we've talked about VNETs and subnets and how you communicate from your on-premise network to Azure. But one of the core ways that you actually communicate within, well, networking as a whole is DNS, or domain name services, or domain name system. So Azure has its own DNS called Azure DNS. It's a highly performant and scalable naming service. It's a way of converting a domain name, so something like google.com, into an IP address. So like the website I showed you previously, this IP address, it's quite hard to remember such an address, so you could use a domain name to make it easier to identify and communicate to various websites. So this is where DNS comes in. DNS within Azure is highly available and resilient. So as with everything that Microsoft offers, there is a core level of resiliency and availability. It's not a guarantee that there will never be an outage, but it's at least a way of ensuring that there should be minimal disruption if there is a problem. For Azure DNS, it's actually using Microsoft's own kind of global network of name servers, so it's not just in one region. It's a global service. And so when you query one of their DNS servers, you're generally querying the one closest to you. So if you have somebody in Singapore, they'd be talking to some a DNS server in Southeast Asia, versus if you have somebody in America, they'd be talking to East US or West US. The benefits of using Azure DNS over other DNS servers out there is that if you're using other services within Azure, Azure DNS uses the same security features for protection. So the role-based access to protect changes, you can implement kind of resource locks, so that prevents accidental deletion or modification of your resource, your records within DNS, and means that your networking configuration and your name configuration sort of is locked down, so only a subset of people can change things. So once you've got your name resolution working, so you're converting your domain names into IP addresses, how do you route things within the virtual network? So by default, Azure takes all of that on board and just uses its own default routing. So this is using either internal Azure DNS servers, or if you've got external DNS servers, it will use those as well. But it will route the traffic to where it thinks it should go, whether it be to another virtual network, to down a VPN tunnel to an on-premise network, or just out onto the internet. You can override this routing, however. So there is the concept of user-defined routes, where you create your own routing tables, and this is where you can suggest that rather than going straight out to the internet, you need to pass through a different virtual network first. This is getting slightly more complex and in-depth than you probably need for the Azure for the AZ-900, but it's something to be aware of, in that sort of within the networking framework, you could have an Azure firewall or something doing scanning and to ensure protection of your traffic in and out of Azure. And so there are times where you want to break away from the default routing that Azure offers, and to do this, you're using your route tables to create user-defined routes within your virtual networks. It just gives you that kind of greater control over where things should be. So, in summary, virtual networks, they're there for segregation and isolation of resources from each other and from the internet. There is a way of connecting the networks together as you need to. This is through VNET peering. The resources within a VNet or peered connection can communicate with each other, and the subnets with the network security groups and user-defined routes are a way of routing and filtering traffic as you see fit. For connectivity into Azure, you've got point-to-site VPNs, which is where you've got multiple laptops or desktops connecting to Azure from multiple locations. You've got the site-to-site VPN, which is a headquarters or office location connecting in through a firewall and a dedicated connection. Or you've got ExpressRoute, which is the step up from a site-to-site VPN that is communicating at a lower level in the networking stack, avoiding going across the public internet. All of this is supported by Azure DNS, which is the Azure hosted version of a domain name service for name resolution to resolve any kind of names to IP addresses, whether they be public or private. I think that's everything. Any questions?